This is the pre-calculus sample problem, spring 2018. Another week, my pre-calculus students are going to be having what they call the ACP, or Assessment of Course Performance at District Test. And so this is a sampling of problems that are similar in rigor and content to that test. Now, there are going to be 21 problems in this sampling. There'll be 28 problems on the actual test. Number one, the graph of an ellipse is shown. Which equation represents this ellipse? Now, this one can be done without a calculator. And to do that, we have to understand a couple of things. We have to understand the center of an ellipse is the coordinate pair h, k. And the standard or general form of an equation of ellipse is x minus h squared over, I'll say b squared, and I'll tell you why in a minute, plus y minus k, or y minus k squared over a squared. Now, why did I put a squared underneath the y term and not underneath the x term? Because we have a vertically oriented ellipse, and then we set all this equal to 1. And so we have the point right at the center, and we can kind of look at where it is on the graph. We have this point, apparently it's going to be the point center 1, 2. And what that means is that we're going to have x, and h is 1, so we're going to have x minus 1 squared plus y, and we're going to have minus negative 2. That's going to be negative 2 here. Let me get that right here. That's 1 comma negative 2. So we're going to have y minus negative 2, which ends up being y plus 2 squared. And we're going to have that equal to 1. And then our semi-major axis here is going to be the distance from the point to the vertex down below, which will be 5. So A is going to be 5, and we square that. And then our semi-minor axis is going to be the distance to the left or right edge from the center, which is going to be 3. So we have 3 squared. And so therefore, it should be pretty apparent what it is. We have, looks like D is our correct answer here. Okay, we have, wait a second, bx minus 1, oops. No, not D, rather C. So that'll be our correct answer. And just to be certain, we can put that in our graphing calculator. And to do that, we get a graph page, and we go to Menu, Graph Entry Edit, 3 Equation Templates, and 4 Ellipse. And create form. You only get one form here. So we're going to put x minus 1, and then we had, what was that, 3 squared underneath the x, and 5 squared underneath the y, and y minus negative 2, so put negative 2 here, and graph this, and we see one that's precisely the one we had been given the graph of here. So C is our correct answer. 2. What's the rectangular form of the curve given the parametric equations x equals t plus 6 and y equals 5t minus 3? So, and we have all the equations in terms of y, all the answer choices. what I like to do is take this equation x equals t plus 6 and solve for t. Well, to solve for t, you subtract 6, so t is going to be equal to x minus 6. So this value, x minus 6, we can take it and put it here, right in for that t here. I'm going to continue down below. So we have y equals 5 times quantity x minus 6. And then we got to bring down this minus 3. And then distributing out here, we have y equals 5x. And then 5 times negative 6 would be minus 30 minus 3. That's going to be y equals 5x minus 33. So A is our correct answer for problem 2. Next, 3. The cable holds a 80-foot pole straight upright as shown. So here we have our pole. It's going to be 80 feet in length. 80 feet here. And our cable, that is our unknown. That's what we're trying to find out. Well, the trigonometric ratios, main ones we use are sine theta, cosine theta, and tangent theta. And sine theta happens to be opposite over hypotenuse. And in this case, we're really trying to find out what hypotenuse is here. So we would say the sine of our angle, 62 degrees, is equal to our opposite, which is 80, over our hypotenuse, which is our unknown. We call it x. One thing we can do here is use the reciprocal ratio, and to do that, we'll say the reciprocal is cosecant. So do cosecant 62 degrees equals x over 80, and then you could say x equals 80 cosecant 62 degrees. So and we are in degrees here. We get 90.6056. And then we just kind of look at what they're looking for here. We want to the nearest tenth, and so that would be rounded 90.6 feet. So let's go ahead and look at this here. We'll say 90.6. Just fill in the places here. 9 goes here. 0. Our decimal point here, and then 6 right here. So that's what it would look like bubbled in. You could use numerical solve here, like I said earlier. Different ways of doing this problem. Next, what are rectangular coordinates for the point 5, 5 pi over 6? Well, for this, x equals r cosine theta, y equals r sine theta. And I will solve. Our cosine is x and our sine is y. And you have options. What I would do is, if your calculator is in degrees, if you just convert this radian measure, and it doesn't really say this, rectangular coordinates for the point, when you have a point written like this, especially in opposition to rectangular coordinates, that means that this coordinate pair is what we call polar coordinates. So we can change this to this measure of angle in radians into degrees by multiplying by 180 over pi, and we cancel. When we work all this out, we're going to get 150 degrees. I'll spare you the trouble. So x is going to be r. Well, in a polar coordinate pair, r is our first term here, which is 5 times cosine 150 degrees, and y equals 5 times sine 150 degrees. So we go here, we say 5 cosine 150 degrees. We get that number here, and then 5 sine 150 degrees. We get 2.5. So we get about negative 4.33 and exactly 2.5 here. So the only place we get a y coordinate of 2.5, which is the same as 5 over 2, is going to be here in answer choice A. Okay, so it's going to be A. And 5 squared, negative 5 squared 3 over 2, we can go over here. Negative 5 square root of 3 over 2. What do we get? Yeah, negative 4.33. So A is definitely our correct answer. This one shouldn't be too hard. Next, what is the exact value of tangent negative 19 pi over 6? Again, one way to do this is just to, if your calculator's in degrees, you want to leave that way. You can just say, okay, I just want to convert this into degrees. So I'm just going to say negative 19 pi over 6 times 180 over pi. And pi over pi will cancel each other. So we're going to have a tangent of negative 19 times 180 degrees now over 6. So we go to our calculator and we say tangent negative 19 times 180 over 6. We get negative 5.77. So not 5.77, and put negative 0.577. That's better. And obviously these answer choice C and D with that are plus, you put this in the calculator and you get negative square root of 3 over here. I'll just go ahead and do it. Negative square root of 3 over 3. What do we get? Yeah, negative 0.577. So it's going to be answer choice B. Next, 6. Triangle ABC is shown based on information there was approximate length of AC. And so we want this distance AC over here. Now, we do not, what we are looking for in solving these types of problems is we have a known opposite side opposite a known angle. We'll use law of sine usually, except we don't have what B is. Well, to find what B is, we know we're going to have 180 degrees, minus these other two angles, which are 85 degrees and 41 degrees, which gives us 54 degrees. So 54 degrees is our side here. So just working an equation, we have x over sine of 54 degrees equals 10 over sine of 41 degrees. And we go to our calculator. I suggest numerical solve menu 3.1. Very handy feature on a TI Inspire CX calculator. So we'll say x over sine 54 degrees equals 10 over sine 41 degrees. And we go over here to the right and just put comma x. And for that we get 12.33 roughly. Yeah, answer choice C. Should be quite an easy problem. Very easy problem, but still you have to do a little extra step. They'll try to make these problems a little harder by adding a little extra step, like having to solve for angle B before an easy law of sines problem. 7. If cosine theta equals 5/13 and sine theta is less than 0, what is cotangent theta? Well, a number of things are helpful to you to do this. One thing I like to do is you can just kind of sketch things out. Well, what are we going to sketch out? Well, cosine is going to be adjacent over hypotenuse. So we can come over here and say adjacent is 5. To the right, and hypotenuse is 13. Well, if cosine is positive and sine is negative, what does cotangent have to be? It has to be negative, because cotangent is going to be equal to cosine theta over sine theta. Or, well, we'll get into that. It's going to be, when you simplify it out, it's going to be adjacent over opposite. And so if we have our hypotenuse is 13 down here, and what does this side here have to be? Well, it's going to be, using Pythagorean theorem, 13 squared equals 5 squared plus b squared. And subtracting out, we have 13 squared minus 5 squared. When you work that out, you get 144 equals b squared. And so therefore, b is going to be equal to plus or minus 12, positive. And we're going to go down here. We know it has to be negative 12. And so our adjacent is 5, our opposite is 12. So we get cotangent theta equals 5 over negative 12, which really simplifies to answer choice B. Yeah, this one was one of the tougher type problems. Just kind of look out for the relationships and you should be okay on this. 8. A polar equation is used to produce the graph of the rows shown. I'm just going to graph answer choice D. add graph, and go to menu, graph entry, edit, and 5 polar. We're going to put in 3 sine 2 theta. And get theta, we press that pi key and go over to the right. Press that, we get this. Now, one thing that is a little tricky on this is the answer choices. If you put in answer choice A without regard to radius, you will pick A and don't look any further. But what you have is, you can see on this polar graph paper, we have a radius of 1, 2, 3, so we get a maximum, we get a radius, which could be the maximum amplitude, will be 3. So that disqualifies A. So therefore, D is our correct answer. Just watch out for that. If you get something that looks right, just do some further analysis to see if you're not being given a trick answer. Now, in the intersection of a plane and a double nap cone, it's shown in the diagram which type of conic section is formed by this intersection. Well, a one that is parallel to the base of the cone is going to be a circle, which definitely this is not. One that is perpendicular is going to separate into a hyperbola, which this is not. This is answer choice B, an ellipse. You're going to get a problem like this, the easiest problem in the test. Good luck with that. Just be careful about that. 10. A helicopter is flying from downtown Dallas to downtown Fort Worth. The distance between the two cities is 32 miles. So we're going to find this distance here by the question mark. I'll just put X over here. And we can use the fact of a transversal. We know that this angle in the right corner has to be 35 degrees. We know this one in the left corner has to be 45 degrees. And then the one remaining, we can do it one of 2 different ways. We can subtract both of these from 180 degrees, or that's what it ends up being. So if we subtract from 180 degrees, we get 100 degrees. So that's going to be our ratio we use. And again, like we did earlier, that's going to be a law of sines application. So the ratio of 32 to the sine of the angle opposite, which is 100 degrees, is going to be equal to our distance x over the sine of 35 degrees. We can just go to our calculator now and go get a calculator page. We'll do the numerical solve. 3, 1. We're going to say x over sine 35 degrees equals 32 over sine 100 degrees. And we go to the right here, we put in comma x, since we're solving for x, we get 18.64 roughly. So 18.64 miles. So A is going to be our closest answer, definitely. Number 11. Which equation represents a hyperbola with foci at -8, 3 and 4, 3 and a transverse axis that is 8 units long? Well, first of all, to find the foci, we're going to look for the center. What is the center? Well, the center is going to happen where x is going to be equal to the average of -8 and 4, our x coordinates, and to find the average of those two numbers, we divide by 2. So we get -4 over 2, which equals 2. And so for x, if we have that x comma h, we're going to look for x minus 2. Okay, because we're going to be to the right here. X minus 2. So anything without x minus 2 is gone. So d, x plus 2, gone. Okay. What else? Trouble seeing this here. Yeah. So x minus 2, that should be it here, and 3, yeah, it's going to be 3, so that's going to be minus 3. It's going to be x minus 2, and 3 would be this. It's going to be 16, let's see, 4, 3, next 3, 1 plus 3, and that's going to be at negative 3 at 4, 3. Oh, it's going to be negative 2. That's where I messed up. Okay. Yeah, we're going to get x plus 2, and the transverse axis, it's going to be answer choice D. I got confused. I just didn't figure that out. So anyway, D is our correct answer. And why do we know that? Because our transverse axis is going to be, our semi-transverse axis is going to be square root of that, because a squared is going to be equal to 16. So therefore a is going to be equal to 4, and that's what will work out for a transverse axis of 8, the semi-transverse axis being 4. So D is our correct answer. Next, 12. What is the exact value of trigonometric function cosine negative 870 degrees? So just real easy. You got cosine negative 870 degrees. We're in degrees. We get negative 8.66, negative 0.866. So that's going to be negative square root of 3 over 2, I believe. So negative 0.866. So A is our correct answer for that one. And there we go. 13. The diagram below shows a boat that's anchored at a point B in a river. There are 2 boat ramps on the far side of the river shown by points A and C. The boat is 120 meters from ramp A and 150 meters from ramp C. If measure of angle ABC is 110 degrees, what is the approximate distance between the boat ramps to the nearest meter? Okay, so the equation is going to be this: c squared equals a squared plus b squared. What does this look like? Pythagorean theorem, except we have adjustment minus 2ab cosine big angle C. And so we want to find this distance here, which we'll call C. So we'll say, we'll call question mark equals C. So we'll say c squared equals, we'll say this A is 150 meters, we'll call that A here. We'll call this other side B, plus 120 squared minus 2 times 150 times 120 times cosine 110 degrees. And now just going to our calculator, we'll go to control. No, I don't want to do that. I want to just go to menu. Let me escape out of that. Menu, numerical solve. We will say c squared equals 150 squared plus 120 squared minus 2 times 150 times 120 times cosine 110 degrees. And we go outside here. We're solving for c, so we put in comma c, make sure that we are in degrees, and we get 221.84. So that's going to be in meters. And we went to the nearest meter, so we said it's approximately 222 meters. And so we go here, let's see, 0, 1, 2, put in 222. So we just go like this, 2. We just need 3 consecutive 2s. People are tempted to put out a whole bunch of decimal places, but try to pay attention to what they're asking for, just to be sure. We don't need to put a plus sign in that program. I think has default pluses in there. We could if we wanted to, right? We could put a plus. Next, 14. What is the reference angle for an angle that measures negative 17 pi over 4 radians? There are just so many different ways we could do this. One thing you could do is you could convert this radian measure into degrees and then just add 360 till you get an angle that you can work with, and just look for that. I don't know, let's just be consistent with what we've done. Let's go ahead and do that. I don't think that's the most, if you know what you're doing, it's not the most efficient way to do it. But then we cancel that, so we get, our degrees are going to be negative 17 over 4 times 180. So we get negative 765 degrees. And we can just add 360 to this. To get between, we can do it 3 times, right? Do we have to do it? I don't know, we could just try it, right? Let's go ahead and do it. We'll say plus 360 plus 360. So get negative 45 degrees. That's going to be, and then if we add 360 again, we're going to get 315 degrees. So what that's going to end up being is this right here. Okay, we're going to be to negative 45 degrees, which is coterminal with 315 degrees. And our reference angle is our smallest positive angle to the x-axis, so it's going to be 45 degrees. And if you go ahead and look at these and convert these, you're going to find out that pi over 4 converts to 45 degrees. And if you work all these other ones out, 3 pi over 4, you're going to get 135 degrees, 215 degrees for this one here. No, 225 degrees, excuse me. For this one here, you're going to get 7 pi over 4. You are going to get 315 degrees. But that's disqualified. You can't have a reference angle that's larger than 90 degrees. D is our correct answer. 15. Which pair of parametric equations represents a line that passes through points 2, 1 and 0, -3? You can just kind of try these one at a time. If you take answer choice C, so if we take 2, 1 for C, we're going to get x, which is 2, equals 2t. So therefore, based on that, if we divide by 2, t is going to be equal to 1. And if we likewise do that for the y equation, we get 1 equals 4t minus 3. Well, if we add 3, we get 4 equals 4t, and so just dividing by 4, t is equal to 1, so that checks out. So that could be a correct point. And you try the same thing for 0. At 0, 3, or 0, -3, we plug in for x is 0. Well, 0 equals 2t, and solving for t is equal to 0. And then if we put in place for -3 for the y equation equals 4, we'll say 4t minus 3, and we add 3 to both sides, we get 0 equals 4t, and that translates to t, also t equals 0. So these are both compatible, so C is our correct answer. You can also graph these in the calculator in the parametric mode. That would be another way to do that, and take a look to see which one of these parametric equations next. So we can just do that and take a look at it to just corroborate. So we go get a Control-I, add graph. We go to menu, graph, for parametric. We have equations 2t and 4t minus 3, so 2t and 4t minus 3. And then I think the time-wise will be okay for what we're doing. Press that. So we want 0, -3, and what was the other one? 1, 2. And we can go to trace and graph trace. So we start here at 0, -3, and we go up here to the point 1. We wanted 2, 1, right? Yeah, 2, 1. So both of these points, 0, -3 and 2, 1, are on this the graph of this parametric equation. So that corroborates our answer choice C. Next, 16. Harrison walks to the library after school every day. When Harrison leaves school, he walks 16 blocks due west. So we can just, if we want to just write it out, that's the way I like to do it. So west is over this direction, and so we go, or he goes 16 blocks west, and then toward the north he goes up 12 blocks. So we want this little theta over here, and our distance is going to be just Pythagorean theorem. It's going to be, our distance will be 16 squared plus 12 squared, and we work this out, we're going to get 20. So 20 blocks is our ultimate distance, and then our angle is going to be theta equals inverse tangent of y over x. So what is that going to be? We went north 12 and west 16. So inverse tangent of, go here, control I, we get inverse tangent of over negative 16. Well, we'll just say 12 over 16. So we get 36.86 degrees. So our best answer choice here is going to be answer choice B. 17, hyperbola has foci at -1, -2, and 13, -2, and eccentricity of 7/6. What is the equation of hyperbola in standard form? Well, again, our center is going to be our x value, like one we did earlier. It's going to be the average of this -1 and 13. And to get an average, we divide by 2. So we're going to get 12 over 2, which equals 6. So we're going to have x minus 6. So anything without x minus 6 is gone already. So we're already between B and D. Well, and to find the eccentricity, we're going to use a feature in the calculator. There's another formula for it, but let's just use the calculator here. Oh, it's getting a bit lazy when you can get a calculator to do these things for you. But we're going to graph hyperbola, so we go menu, 3, 3, hyperbola is 5. And we have an east-west type of hyperbola. So let's go ahead and just put what we have in here. We have x minus 6, and we are going to be over 36, which is going to be 6 squared, and then we're going to have y plus 2, so we're going to say y minus -2, and we're going to put that over 13, so we got to put, it says square, so we're going to put square root of 13 squared, and so there we have our hyperbola. That's off the, we don't see the totality of the hyperbola here. We see the left edge here, but not anything else. But we want to find the eccentricity, so we have enough that we can find that, I think. So if we go to Analyze Graph, we're going to go to Analyze Conics, and then we go to 8, Eccentricity, and we put it on right here. We get 1.16667. Okay, and if we go to our calculator and we put 7/6, What are we going to get for that? Well, we can get a decimalized version of that. Do that. Yeah, 1.667. So our correct answer is D. Next, 18. Which graph represents the curve given by the parametric equations x equals t squared minus 3 and y equals 2t for the interval from -3 to 3? And one thing you can do is kind of look at the arrows. Which way do the arrows go? You want to go the arrow in the direction of time. That's the only one that's going to make sense. So if we look over here at our sketch, in S choice C, we have the arrows and going from t equals 3 to t equals -3, and that's not the way time works. Time works going forward. And then likewise, if we look at answer choice B, we're going from t equals 3 down in opposite direction to t equals -3. So neither of those is going to work. So now we're really between answer choices A and D, and for that we can just go to the calculator, say okay, Control I, add graph, and graph parametric, menu 3, 4, graph parametric, and so for that we just go to t squared minus 3, t squared minus 3, and y equals 2t. And down here is where it gets a little tricky, in that we're going to need to get the right interval here. So we're going to go from 3 here on the positive side, and we go to the left there, we're going to put in -3, and then we graph, and we get this. And so when we go to trace, it's going to give us everything we need to know, because it'll just be the direction of the arrow. And so we go to 5, trace, 1, graph trace, and we see we're given an initial point there. And as we go to the right, we see time is increasing as we go to the right. So the direction of time is going up to the right here. Eventually we get to 3. Okay? So it's going to be the one where the t ends up here at 3 and not at -3. So it's going to be this one right here, answer choice A. So just a little analysis makes this one not too hard in conjunction with your TI-Nspire CX calculator. TI-84 will work quite well with this as well. Next, if U equals the vector 8, comma 12, comma -3, V equals vector -4, comma 7, comma 14, W equals vector 2, comma -5, comma 6, what is 3U minus 4V plus 2W? Now we're fortunate, if we look at our answer choices, none of them is the same, which means that just by analyzing the first term here, which I'm starring, the 8, the -4, and the 2, we should be able to figure out everything we need. And so if we take, we want to find 3U. So 3U equals 3 times 8, comma 12, comma -3. And then we're going to say -4V. So -4V equals -4 times, same thing here, -4, comma 7, comma 14. And finally 2W, so 2W is equal to 2 times 2, comma -5, comma 6. And so just kind of working it out for the U business, we're going to have 3U is going to be 3 times 8, and it's going to be minus 4v, so minus, we got to be careful there, because if negative 4v, you'd be like adding, so minus negative would be adding, so it'd be the same as 4 times 4, 4 times 4, and then finally we're going to add 2w, so we're going to add 2 times 2, so we're going to have 24 plus 16 plus 4, and that's going to be adding all up to 44. So our only possible answer is D, and then to be thorough, we can go ahead and try the other these second values by multiplying 3 times 12, negative 4 times 7, and 2 times negative 5, and so on, to find our second value in that composite vector. Next, 20. If r equals 4 comma negative 2, which graph represents negative 2r? So to find, negative 2r is just going to be r times 2, so we can just take negative 2 times this vector 4 comma negative 2, and what we get here is we'll get negative 8 comma 4. And so all we have to do is look where we go 8 to the left and 4 up. That's going to be answer choice C. So that should be really quite easy, just multiplying this vector out. Next, what is reference angle for an angle that measures 300 degrees? We already had a reference angle problem earlier that was more challenging. But for this one, if we have 300 degrees, that's going to be an angle that finishes right about down here. So we'll go, that's 300 degrees. And how do we find a reference angle? The reference angle is going to be this distance right here between that terminal side and the x-axis, shortest possible positive distance. So our answer is going to be 360 degrees minus 300 degrees, or 60 degrees. That's all there is to it. Just out of hand, you should say C or D cannot be right. They're just not possible. You need to be between 0 and 90 degrees. So anyway, that's all these sample problems. I know I kind of stalled on one of those problems for a while, kind of figuring out sort of the mistake I made, but eventually got it figured out right. Good luck, and thanks for viewing.